Good evening, everyone. Thank you for joining us once again. It's been a wonderful time. Yesterday, we started a conference and we continue today. Yesterday was really fantastic. We're really talking about how to make the best out of our careers as engineers, regardless US or Nigeria. And our focus was how to actually thrive with an engineering career in Nigeria. The first speaker spoke about career paths in engineering and how we can actually create. I think one of the things that stood out for me yesterday was the speaker said, your own business is your career. Okay, so you're working for somebody, that's their business, but your business is your career. And so we have the responsibility to ensure that we build our career. So that was really, really very interesting and really wonderful to hear. Today, then the second speaker also talked about, the things that we need to be in our toolbox so that we can actually be successful. All right, just 1 minute. I think I'm going to have to mute. Okay, good. All right. So the speakers, the second speaker actually spoke about the things that we need as an engineer to be in our toolbox and as a modern engineer. And she talked about 3 key things, I think, which is the skills that we need. We're very familiar with technical skills, but what are the other skills that we need? Do we have them? She talked about, the softwares that we need and also the awareness of working to standard. So I want to believe that we're able to take all of this away from here yesterday. And tonight, we're going to be continuing with today's theme, which is product development and new technologies. And, we already have the speakers on the house, and I'm sure that they're already prepared to speak to us, and they're prepared to actually, help us, understand these technologies best, understand how best, even as a Nigerian engineer, how do I fit into this picture? One of the beautiful things about this conference is because all of the people speaking at this conference actually, they had their BSc in Nigeria. And that's really beautiful because it just shows you how, regardless of everything that's happening, regardless of everything that happens in Nigeria, we're still getting the best out of it. We're still getting the best out of it. So I just want to encourage each and every one of us that we can make the best regardless of what situation, regardless of what circumstances. I'm just filling in the title for us now on Facebook. So, but I just want to say that regardless of what we are facing, regardless of wherever our background is, we can make the best out of it as a Nigerian engineer. And that's our focus on this conference. Somebody might say, you know what, yeah, all of these things are good, but I'm not sure about it. But no, yes, it is possible to do that. That is what we're going to be doing. So yes, thank you for coming. Thank you for coming to listen to us. We are now going to continue. I'm going to be introducing our speaker in a minute. And I know they're already here to speak to us. They have wonderful things to tell us. The first speaker will be talking about Industry 4.0, and then the second speaker will be talking about product development. So I already shared yesterday, who we had, End Reality, but I'd just like to reiterate again. End Reality is a part of an NGO called Engineering Empowerment Initiative for Africa. The whole end game is to ensure that as Nigerian engineers, as African engineers, we can make the best of what we have, and therefore using engineering as a tool for national development. And I so much believe this personally because I know that, you just need to look at any developed country and you can see that technology, engineering is at the root of this development. Industrialism is at the root of development. And so I believe that if engineers will stand up, take their place, stand up to be counted, believe in themselves, have the right tools, the right mindset, I believe that we can change Nigeria. And not only can we change Nigeria, we can change Africa, through engineering. And how do we start? We can't depend on the government to do it for us. We all know that's not possible. We need to start by encouraging ourselves, speaking to ourselves, learning from one another, doing things for ourselves. And then we'll begin to understand that, oh yeah, these are some of the things that can help me to be better. There's so many. One of the good things about engineers is they are one of the most brilliant people around. People that study engineering, just need to speak to some of them. Some of the most brilliant, beautiful minds you can find. you know, and I believe that if we can actually translate this brilliancy into innovation, creativity, and products, I know that, you know, we are going to be the best. Nigerians are going to be the best. So please, this evening, I want you to be ready, open up your mind, be ready to listen to the people that have come to talk to us. And I'm sure that these are people that have been able to practice one or two things, and we know they've been successful with it, and we want them to come and share with us so that they can be successful with. We can be successful with our engineering careers. So I'm just going to go on to introduce the first speaker. If you just give me 1 second while I think Facebook is asking us to try and finish up with what we have already put on. Okay, we'll come back to that in a minute. We'll just go back. So I'm going to be introducing to us this evening the first speaker for the evening, and I'll just, you know, try and read this citation right now. All right. So this evening, our first speaker is Dr. Joshua Oweri. All right. So Joshua has a background in mechanical engineering and has PhD in system information science. He has worked in education, engineering, and research. His experience spans across deep learning, computer vision, and self-driving cars technology. Joshua currently works as an artificial intelligence engineer in Japan, where he is specialized in developing and deploying deep learning models for computer vision tasks, such as visual inspection in manufacturing, autonomous car perception, scene understanding, and behavior. Please, can you make welcome Joshua this evening? Please, can you, let me just unmute him so that he can speak to us. Can you make him welcome in the comment section? Just tell him, Dr. Joshua, you're welcome. All right, so I've asked you to unmute, sir, and you can unmute yourself.
Hello, everyone.
All right, we can hear you. All right, so I'm just looking for your video so that I can spotlight you.
Video also, good?
Yes.
Can you see me now?
Or do you want to share your screen, or, you know, what do you want?
Yeah, I'm gonna share my screen.
Okay, all right. So I'm
just. I have a presentation, yeah.
All right, just a minute while I make you a co-host so you can, yes, please. So go ahead. I'm just looking for you in the videos, and then I'm going to spotlight you.
Okay.
All right, so you'll be hearing, the next voice you'll be hearing is Dr. Joshua. All right, good. We are now.
Okay, please let me know if you can see my screen.
Yes, we can.
Okay, thank you so much.
Well, let's just hear from the comment section if they can see your screen. All right, so yes, they're saying they can see your screen.
Okay. Yeah, thank you so much for this opportunity to give this talk in this this conference. Sorry I couldn't attend yesterday, but I'm sure that it was a great time, and I'm looking forward to also learn today even from other people. So yeah, I'm going to be talking about trends in engineering and prospects and opportunities, basically kind of focusing on some new ideas, some emerging ideas that have been coming up, and we all know about Industry 4.0. These are kind of new ideas that are, I would say that the new dispensation we are in now in engineering, and I'm going to kind of focus on this. But first, I just want to give a background of myself, and I did my mechanical engineering degrees in Nigeria, first in Futa, Federal University of Technology, Accra, and graduated 2019. Then I went to do my master's in University of Abeokuta. Then in 2015, I moved to Japan, where I started my PhD, and I graduated last year in the Department of System Information Science. My focus was basically on computer vision and deep learning, as you've rightly heard. Now I work as an artificial intelligence engineer with a startup here in Tokyo. We basically work with other companies to build um, software, to build a solution for different applications, mainly in manufacturing, self-driving cars, and also sometimes like in biology. So I think that is out of scope, but at the same time, this is an application that can work for all these areas. So this is what I'm working on. I'm also like an AI consultant presently, also like also consult on the various ideas in AI. So this is what I do. And so the summary of what I'm going to talk today is basically, I want to talk about the current state. I'm just going to start there so that we go from where we know to where we might be a little unfamiliar with. As a matter of fact, if you have any questions, please just let me know. You can send it, and probably I can answer them as I'm going on. And then I'm going to talk about the latest trends in engineering industry, and I'm going to talk about some applications that I've worked on personally. This is just to give us an idea, because I feel that the latest trends in engineering is very wide, is very broad. The applications are also diverse. So it's better to have something that you can easily see and something you can easily relate with. So I'm going to talk about some of the projects that I worked on and how, I mean, it's uh, really in engineering, because now, I mean, a lot of people see, okay, I did mechanical engineering, but now I'm in system information science. The truth is most of the applications are also in engineering space, and we work with other classical engineers also. So this is one thing to really note. And I'm also going to talk about like my own thoughts about future proof pathways, how you can channel your, how you can, what actions you can take right now as an engineer to kind of future proof your work. Because I think the area I'm working in right now, I know most of you have heard of artificial intelligence. There are some developments that should concern most engineers, and how you can actually protect yourself as to what the future of work is actually going to be. So first, let's talk about the current state. Yeah, the truth is the principles and the basics of engineering has not changed that much. As you can see, I'm just kind of juxtaposing like an old car and new car. In this case, you have a internal combustion engine that actually runs the car. If you look at the principles, they have been the same for over 60 years. However, the packaging has changed, and there are a lot of new components that have been added that makes the system more efficient and more optimized. So this is basically engineering for you. Um, the best way to say it is that the tools have become more sophisticated and efficient. Of course, in order for us to be able to do our work very well, the tools become more efficient and sophisticated. And I can compare this with the times that people usually do engineering drafting by hand. And if you have to create maybe 100 drawings for a particular client, you have to do it by hand. And of course, there are ways to multiply, but the truth is the speed at which you do a lot of engineering processes is much more faster than it used to be before. And talking about industry 4.0, and this is just a comparison and how things have changed over the years. In industry 1.0, you have mechanization. Basically, this is the foundation of a lot of engineering that we see today. Most of the machines run on steam power, and that is when the industrial booms kind of started. And 2.0 kind of led us into mass production in assembly lines. And if you know the story about Ford car, this was the product that actually gave us a mass production. And 3.0 gave us automation and basically adding computers and electronics into the production process or in the process. Now we have a new layer, which I think is the internet. The internet is changing a lot of things right now, and this is, if you add this new layer on top of industry 3.0, you get industry 4.0, which means now that you can do a lot of things on a scale that you cannot do it before. First, the scale is increased and the speed is also increased. And there is also a miniaturization of the space at which you can do things. So in the sense that now you can work with someone who is maybe in another continent, and you have a team that is scattered all over the globe, and you're working on the same project. Years before, this is kind of not possible. So this is a new, like a new trend. And what you find out also is that it is opening up new opportunities, opening up new ways of doing things. And this is the things that I'm going to talk about in the next session. So the latest trends that we see for me as a person, and through my research and the things that I've experienced over the years. Number one, I'm just going to list them now, then I'm going to go into details later. Now you're having like what we call intelligent engineering. Basically, not just the brute force way we used to do things before, but now doing a more intelligent way and a smart way. And there is what we call multi-experience development, big data. I know most of you have heard this before. Big data. The truth is, most of our engineering firms and the companies have generated a lot of big data, a lot of data that over the years. And in today's economy, or in today's landscape, the data is very, very useful. You can uncover a lot of, how do I say, you can uncover a lot of trends. You can uncover a lot of information by just looking at the data over the years. And this engineering data is also part of this data. And so you see that a lot of companies are turning into big data in order to answer a lot of engineering questions. And basically, that's one thing. Then another thing is rapid prototyping. With the space of development and the speed that people want things to be developed, there is the old ways of going through the normal process has changed. And so you have this new process where you can quickly go from the product concept to the finished product in a very short time. And this enables you to go over the cycle many times until you get a very refined product at the end. And the final part, which I think is, it's not really my area, but I keep seeing this a lot, and it's somewhere that really any engineer really wants to think about. And this is basically because there is a move from fossil fuels into renewable energy. And when you're talking about renewable energy, it means that you have to find a way to store the energy. And this is why battery energy storage system is very, very important in today's world. And so now let's go into details. Intelligent engineering is basically consists of three things. And number one is the Internet of Things. In this case, what is Internet of Things is basically having like connection between equipment, between computing devices and different devices, machines, sensors, name it, anything that you can actually connect to the internet, and connect everything to the internet. And not just that they're connected, but they can also communicate and interact while connected to the internet. This means that this opens a lot of opportunities, in the sense that now when you're working with an equipment, or you're working with anything, it's easy for you to get real-time data analysis, real-time action, real-time responses, just because now the equipments are connected over the internet. And add that to um, the next part, which is cloud computing. Cloud computing is basically on-demand availability of computer system resources, especially storage and computing power, without having to have it in the physical form like you're having. Like, but many years ago, people have just the computers and they work with it. And of course, working with an equipment, you work with it there and there. But with connection to the internet, you can expose this computer to be able to do things that are even much more than its own power. This allows us to carry out high computation operations at low cost, on low cost and low power devices, simply by connecting to the internet. So what you're doing is you are offloading the large computation. Imagine if you have to do a large computation, maybe finite element analysis of a very complex material, and your computer is not powerful enough to do it. But with cloud computing, you can have a single mainframe that all the members of the team uses, and then you offload the computation requirement on this cloud-based server, and then which means you can have the access to this. All you have to do is send a request, and you get a response from it. So this is cloud computing. And the last part of intelligent engineering, which is what I call automation and autonomy. Of course, automation is not new. That kind of started in Industry 3.0, but autonomy in this sense is basically we're giving machines the ability to act and make intelligent decisions without human interventions. If I have to describe this in one word, I would say robots. And I'm sure a lot of us have heard about robots before. Basically, trying to make manufacturing or production in a way that is robotic. That is, you just have to in the factory of the future. Probably you would have only one person, and you will have a big factory as big as with a lot of equipment, maybe thousands and thousands of them. And what you have to do is just press a button, and it gets to work, and it starts working, and it gives you the same thing that you're having now with the thousands of people. This is where industry is going, and this is what autonomy exposes us to be able to do. For us to be able to give the machines the ability to do human-like things, basically. This is autonomy. Then the second part of the second trend that I've seen also is what I call the multi-experience development. Now, and I know maybe some people would have heard about virtual reality and augmented reality. Nowadays, you realize that there is a high cost of education with even new recruits or new engineers that are coming into a company. So suppose you're working in GE before, now you move to maybe Tesla. The equipments that you're using in GE are not the same that you'll be using in Tesla. There has to be an onboarding process. There has to be an education process, and it turns out that the cost of doing this is very large. And with the technology like virtual reality, you can be able to um, give give an experience, an educational experience to someone who is going to learn some new tools. And this is what you can see is basically generating like simulations and images on environment that kind of mimics what you would have in the real sense, and kind of this is more like an immersive experience. Imagine learning about maybe how to fly an aeroplane. This is what is being used uh, so much even now for airline pilots and everything. They have to go through this in a virtual environment first, because nobody wants to incur the cost of crashing an airplane just for you to be able to learn how to do it. So this is one area that is very, very important for education in engineering and onboarding process for engineering companies. And as you can see in this image, this person is trying out new ideas, is designing in a virtual environment. The other part, which is really, really related to it, is augmented reality. Basically, you are superimposing computer generated images or computer generated information in the user's view. So imagine that you have a technical problem uh, on the floor or in the manufacturing space, like you can see in this image, and the person is not technically has the qualification, but maybe it's a new problem. You can find a way to create a solution to this problem that kind of puts the technician um, through the process of solving that problem by creating this kind of augmented reality environment. So as you can see here, I don't know if you can see my pointer, this woman here is wearing this augmented reality headset, which is actually this almost the same with what you have in virtual reality. But the difference in virtual reality is that virtual reality headset is covering all your total field of view. So you are not seeing anything except the virtual environment. In augmented reality, you can still see your environment, you can still see what is happening around you, but there is a new reality that has been added on top of what you are seeing. So you can see real-time solutions to problems that you have, and it can tell you, looking at that thing, I mean, the computer can see what you're seeing, and at the same time it can tell you, this part and this part, this is what you need to do next, this is what you need to do next, give you the instructions on what you need to do. These are emerging areas in manufacturing, I think. And why I say it's emerging is because this is not it's not mass production yet. These are new areas that anybody can go into, and in 10 years time you become an expert in this, and you when the technology has really blown out. Now going to big data analytics. Data science is one very big area of big data, and data science is more like the a combination of a lot of things. Actually, it's basically the science of understanding and analyzing the data, trying to uncover eating patterns, trying to uncover eating information, trying to know what exactly the data is trying to tell us. I mean, if you have a bunch of data, in this case, big data, terabytes and petabytes of data that is being generated every day. Imagine you have a manufacturing floor that gives you the state of every of the products every day, and you have a very massive production line. And it's hard for one person to just look through all this data and make any sense of it. But big data or data science can give us the abilities, kind of exposes us or gives us the principles or the tools that we need to be able to uncover really, really useful information from a lot of data. And this is what big data is. And it has many areas actually. So like you've seen here, there's computer science in it, there is machine learning, there is statistical mathematics, there is business. Of course, there's also software development. And the other part, which is also like it, is machine learning. This is kind of a small part of data science because it's more like the most popular part of data science right now. Data science has a lot of things, but machine learning gives the ability to automatically learn and improve like experience without really programming. So I'm not sure how many of us did programming in school, but I'm sure that you should have some idea of programming. So imagine not a classical programming um, way. You have to tell the computer what it has to do. So you have to say line by line what the computer needs to do. So suppose you want to put off an AC when the temperature is at 20 degrees. So you can write the instruction as when the temperature is 20 degrees, then AC off. This is a simple kind of instruction. But there are some tasks that are more complex than that, which might be very difficult for classical, how do I say, classical programming to do. So this is where machine learning comes in. You can easily use machine learning to do this kind of things. One very popular area is face recognition. So if you have to write a program for the computer to recognize a human face, what instruction would you have to write? You realize that it becomes very complex in order to be able to describe a human face in a way that the computer will understand. So machine learning gives us the tools to be able to allow the computer to learn by itself just by looking at the data and being able to recognize the output of this data. So machine learning is actually encroaching a lot into manufacturing and engineering these days. And I'm going to share some examples where this has been used. And the other part is rapid prototyping and development. Sorry, I'm not sure if you're following me, but I would really like if you can get some feedback right now. Just to make sure that you're following me, you can just send a text. Is everybody following?
Yeah, we can hear you.
Okay,
They're,
good.
they're all muted, so they can
All
put it
right.
in the comment section.
Yeah, all right, good. So now rapid prototyping is there are two areas, 3D computer aided design and engineering and 3D printing. 3D computer aided area and design and engineering, it's not really new, but it's still a developing side of rapid prototyping, because in the beginning we started doing drafting and computer uh, drafting through computer. Now you can do 3D modeling. Now you can do 3D simulations. Now you can do more 3D analysis of complex systems, and from there you can come and do like 3D printing. 3D printing is it's a new technology, relatively new, that allows us to be able to produce um, products, to make products that are probably too difficult for classical or other kind of um, methods to do. So in production, you have some kind of destructive modeling and destructive manufacturing and additive manufacturing. So in destructive manufacturing, you have a whole block, and then you kind of cut away from this block to make your final model. In additive, in this case, you have nothing from the beginning. You have nothing. Then you begin to add materials in order to make it. So it turns out that 3D modeling can enable us to quickly go from product idea or product concept into final product within a very short time. And this is very useful for not mass production anyway, but for development and for research, and for special cases where it is cost prohibitive to actually do it in the traditional way. And this is a very big area for engineering. And the last part, I'm just going to touch on this. I've already said it before. Basically, storing electric charge by using specially developed batteries in order to be utilized later. For people in maybe electrical engineering, I think uh, this is a very important aspect of power generation, power storage, because the world is moving away from the fossil fuels, and that means that the power, the energy storage has to be very, very good, has to be much more better than it is now. And of course, like for a lot of cars now, a lot of countries are phasing out like fossil fuel driven cars, and we are moving to electric driven cars. And this is a trend, and it's gonna keep going like this. And so the main the main development here is, if we can store energy efficiently, then it is easy to harness energy from wind, from solar, from hydro, and all of these renewable energy sources. And so, talking about all of those, I just want to touch on some application areas that I have worked on personally. I'll just explain them in a bit, and just to kind of give advice, just to kind of give to entice or to give an idea of how these emerging areas are actually moving or are actually being used in even in classical engineering. In the beginning, I showed a car, right? It turns out that I don't know what's happening here. Kind of, I have a, sorry. Yeah, you can see here, this is like a car driving. And the application here is basically you are developing a car that can drive itself. Remember, I talked about internal combustion engine in the beginning. It turns out that there's still so much to do even with a car. So now the world is moving towards um, the cars driving themselves. And if you analyze this, you realize that um, humans need to understand a lot of things before they can actually drive a car. And one of it is being able to understand which other objects are in the scene, right? So in this case, you have this model or this car that is driving itself, but it needs to be able to also see all the other objects in the scene. And this is what's happening in this case. And you have to be able to know where all the other cars are in the scene. And if there are persons also, maybe there are some cases where you would see that, it needs to know that there is someone. Okay, you can see people passing in front of the car now, and it can recognize these are persons passing. So you don't want like a car to drive when a person is in front of it. So these are things that we're kind of developing for transportation engineering, for transportation technology, for even for the car itself. Cars of the future, probably you might have seen this in science fiction movies, but the reality is that cars of the future would probably not have a steering wheel. They will be able to drive themselves, and they will be able to do all of these things efficiently. Yeah, so move on to the next one. This is another technology that I've worked on, which is AI-based visual inspection for manufacturing. There's a lot of visual inspection in manufacturing, in production, in many areas of manufacturing. And one thing eh, that you have to rely on people on is being able to know the difference between a good product and a bad product. So when you're producing, you want to be able sure that you want to be sure that what is coming out of the production line is what we expect. And this is just the basic idea of visual inspection. And here we're developing this kind of model that can identify, that can differentiate between a good product and a bad product. And that's what you can see here, an anomalous product. So we were expecting this at the end, but somehow there's some color difference in the product. This is not done by a human. This is done by a machine, and this makes it easy to be able to do this at scale. And you can also transfer the same idea to other objects. So this is a toothbrush. Um, it's supposed to come out really tight, but you can see the toothbrush here on the bottom here. The motor can recognize that there's something wrong with the toothbrush. And this is another example here. You have a bunch of screws here, and the model can recognize that this one is kind of shorter than it should normally be. And this is represented by the anomaly map that you can see here. So this is a kind of anomaly map that shows that there's something wrong with the image. So this is an application that is really, really popular in manufacturing, for visual inspection for manufacturing. Soon there will not be need to have people actually do this anymore, because the computers will be able to do it automatically. And here is a video. Basically, this is a concept of video, but there are systems that are actually modeling this kind of scenario right now. And what you see here is AI assisted manufacturing. So you have a robot and you have a human there, basically working together to achieve the same objective. And what the human is doing here is basically using gestures to control the human, to control the robot. So um, you have like objects place position here, and the human is working with this object, and the robot is staying on its own. But then you can summon the robot to bring you a specific object, and it can bring it to you. You use it, then you can give it back to the robot, and it places it back where it should be. I'm just gonna, oh yeah, I want to show that part where, yeah, so the human puts there, and the robot takes it by through its gesture recognition, and the robot puts it back where it's supposed to be. This is kind of still a kind of primitive idea, but there is a lot of scenarios where this will be useful in manufacturing. So, having talked about these are things that I've worked on personally for myself, but there are some other areas that are very, very that are useful for that going to be used applied with new emergent areas. So there is predictive maintenance, there is factory input optimization, and there is AI assisted product development. So lastly, I want to talk about um, future-proof pathways. What are the things, having known all of this, knowing all these ideas, what are the things that what are the actions or kind of my own thought of how engineering should move, mostly focused on the landscape of engineering in Nigeria itself, and see what can we do or how should we act in order to make ourselves relevant in this new emerging space. So I checked while doing this, while preparing for this, I went on LinkedIn. I checked all the various engineering requirements from different companies, Tesla, Aston Martins, the big companies, and try to see what these companies are asking for new engineers to have. And of course, there are the classical things, know how to do CAD drafting and know the principles of engineering and all this. But there are some new skills that are appearing in engineering requirements, and which is um, emphasizing the things that I've been saying before. And one of it is, and I've been listed here, is basically data acquisition skill and testing. The knowledge of rapid prototyping is it's a skill that is being sorted after by new companies right now, because the production space needs to be really faster than it used to be before. So the ability to quickly prototype and bring out new products is very key. And new engineers are required to know this. And there is hands-on approach with technical experience in engineering, prototyping that comes up again, and also learn modern technologies. Then software use, this is also something that keeps coming up in many of these requirements. Knowledge of machine shop, 3D printing processes. These are new skills that I'm seeing that are coming up for engineering positions. And kind of my ideas from this, kind of rounding off right now. So I think there is a single glue that holds most of these emerging areas together, which is software and computing. Yeah, we talked about internet. Internet kind of gives us all the connectivity. However, the software that enables the internet, or the software that is behind the internet, is what is kind of driving all of these emerging areas, emerging technologies. And number two, the knowledge of software usage and development will be very, very key to be a major yardstick for future opportunities for a lot of engineers. I'm not sure what what you're experiencing in your own area right now, but I think this is going to be a very, very um, key thing to really think about. as the future of work changes. Also, the coming to Nigeria now, I think that engineering education is very capital intensive. I don't know how many people will agree with me on this, but I think that most of the schools in Nigeria, they do not have the, how do I say, the hardware capability or the capital investment to be able to actually do engineering education. From my experience that I've seen outside Nigeria, there is so much lacking in the capital investment that needs to go into engineering in Nigeria. And so there is need for massive investment in hardware for learning and for experimentation. I mean, you have a mechanical engineering departments that don't have the basic equipment, they don't have the machines that they need to use. This is very sad, but this is the situation that we have. On the other hand, there is a lower cost associated with the software education. And this is the point I'm trying to make, even with all of this. Even though the hardware part is very, very hard, and a lot of people say that we are very good with theory, right? We know all the theory, but there's another way to actually practice the theory, to actually actualize it. Is basically channeling it towards software education. And I think there can be a move towards software focused learning while the hardware catches up. It's going to take a long time before the hardware investment for education in Nigeria catches up with the theory that we have and that most of the lecturers have. So we should kind of focus on software focused learning and trying to see how we can bring what we are learning into the software space, because it's very, very easy to actually learn software. And with the Internet of Things, with Industry 4.0, and with the use of Internet, it makes it very, very easy to learn software. Then also the quality assurance in software makes the knowledge easily transferable and adaptable. So the thing, what I mean here is that if you learn a particular software, say I learn AutoCAD, is the same AutoCAD that I would I would use in a different company if I go there. If they use this, if they are using that software, and if I travel outside Nigeria, is that same software that I will use. Compare that with me working with a very old, how do I say, old equipment like an old CNC or old lab equipment here. I would need some retraining to be able to adapt to the new equipment if I move out of Nigeria or if I move to a more advanced place. So I think that software knowledge is easily transferable and adaptable. And coming to the last part, which is artificial intelligence, I think it poses a major threat to repetitive processes in engineering. There's so many parts of engineering these days that are kind of repetitive. Yeah, I mean, we still have to do it because the technology is not there yet. But this is one thing that artificial intelligence will really focus on, and it's actually taking part. Imagine the example I, I mentioned about visual inspection. This is something that probably you need to hire an expert for right now. But in 5 years' time, or 10 years' time, or say 15 years' time at worst, if you have models that can easily do this, then you wouldn't need this kind of person. And as a matter of fact, this one personal experience that I got a contact from a company that wants to work on issues facing a certain process in the production line. And we needed to kind of develop a model that predicts future failure. So there is like it's a production line that kind of fails after some time. It's hard to actually know when it's going to fail, but if we collect a lot of data, if we collect a lot of sensor data, it is possible for us to be able to predict a future failure by using artificial intelligence models, machine learning, and big data. These are the kind of capabilities that we have with the new emerging technologies that are coming up in engineering. And I think we should avail ourselves of this technology And the last analogy I'm going to make is many years ago, before most of us started using, um, before most of us started using like Microsoft Office or Microsoft PowerPoints, when Microsoft PowerPoint came, it became a skill that you needed in order to be able to get a job. Like you have to be able to use Microsoft Office tools, right? Even though that is not, I mean, your main area, that is not your specialization. The years that are coming, the tools are changing, right? And possibly you're going to have to use some kind of software, some intelligent software, some AI based software to be able to show that you know what you know. So this is the way the trends are going. Now, the era of Microsoft Office tools have gone. The new era is being able to um, come up with intelligence softwares that is going to help you to do your job. So this is kind of this for me. This is like the perfect ending. If you have any questions, I will be happy to answer them.
Wow. Thank you so much, Dr. Joshua. That was mind blowing.
Mm,
That was really
you're
mind.
welcome.
Um, I don't know if you have a question, you can type it in the comment section, or if you want to raise your hand, you can raise your hand. So if you just stop sharing,
Yeah. Okay.
Dr. and
Stop
yeah.
sharing.
So please, thank you. That was really mind blowing. In fact, let me just, while we wait for the questions, let me reiterate some of the things you said. You know, it first took us, it schooled us actually, first took us through the difference between virtual reality, augmented reality, kind of told us how everything was interconnected from industry 1.0 to industry 4.0. I'm sure if you look on that, you can see where we are in Nigeria anyway. But yes,
Mm,
it really took us through step by step. And I think, you know, that video of the cars moving, the autonomous cars, trying to get the perception of what is looking at, that was really beautiful. And also, I think your concluding points were so interesting because you said, yes, even though engineering education is capital intensive, and we might not be able to meet up with that right now in Nigeria, but there is something we can do. We can actually go the software route and we can learn about the software. And I thought that was really profound because I was saying something in my talk yesterday, and I was saying that someone might say, you know what, Nigeria is never going to have Teslas or anything. I said, but it's just a matter of time. You'll be surprised people will be using generators to charge their Tesla, actually, because it will become a
yeah.
status symbol. That's going to happen. So it's really interesting because it is, you know, there's a pigeon English. They say, now who know, now who know go know. You understand? If it's what you
Yeah. You're
know,
right.
the software that you know, it's what you know that you can take from places to places. And once people know that you
Mm,
know it, you know, they begin to contact you about these things. And, you know, this, you know, alludes to what, you know, we're talking about yesterday at developing our career. So yes, there is a lot we don't have already in Nigeria, but there is something that we can do about what we have. And I think that was really very interesting and profound. And also for anyone that is interested in artificial intelligence, you can see it's so beautiful. It's so nice. You know, when you were in the lab, I guess that was you in the lab,
yeah.
working,
That was me.
that was so nice, right? Like just
Yeah.
creating something like saying, you know what, pick that for me and give you back. So it's just where the world is going. It's nothing. The world is not, well, it's going to end one day. At least it's not ending now. But while we wait for it to end,
Mm,
let's put ourselves in a perspective, in a place whereby we can actually take the best advantage. So somebody is asking a question. I'll just go and read that question. Okay, somebody is okay. Moving towards Industry 4.0 is challenging. Looking at the standard of education in Nigeria, what are the right resources to develop oneself in emerging technologies? Well, I think he has mentioned it, but I'll just let him have the floor. Do you want to say something?
yeah. Yeah. I think I already said something about that. I think you should just expose yourself to what is happening outside and just look at the skills that you need. In this case, focus on, I would just say this, focus on software part. This is one way, this is one part that you can really accelerate, and you don't have to move outside of Nigeria to actually learn the skills. These are skills that you can learn online just by watching YouTube videos, attending some courses that somewhere else hosted from other parts of the globe. These are, I mean, things you can do. And I think software is very, very, very relevant right now, even in any industry.
Thank you. Yeah, I think that's very correct. You can learn that. Remember, we talked about software yesterday, and I was still saying, even you know, sometimes you need to pay, but there are also free versions. There are also things that you can learn on YouTube and all of that. And you know, definitely these are skills that, like you said, these are transferable skills anyway. You know, whether you're working for it doesn't matter what engineering company you're working for. If you know how to use CAD, is an advantage any day, anytime. So these skills are really, you know, things that are transferable. That's really beautiful. And I hope that, you know, even some of us that are students, some of us, if you're a lecturer and you're listening to us, you know, it's just, yes, we can complain to tomorrow about what we don't have, but we can begin to encourage students and other people alike to begin to work. And that's what happened, you know, writing codes and everything. That was how the fintech institution in Nigeria was about. You know, they were able to break out. Now banks are now creating fintech departments. That never used to be, you know. You used to have to go to bank queue, and you know, we had people 70, 60 years old, 40 years old. Now banks are looking for young people under 27 to train in data management and all of that. And you know, the fintech vibes are taking over the country. So I also believe as engineers, we have a route out of some of these problems. You know, you said, you know, while we wait for people to, because when it is big, I want to believe that when we start making the right noises, start doing the right things, there will begin to be attention drawn to our side. Initially, government wasn't interested in anything fintech or anything like that, but you can begin to see now that people are beginning to draw attention. Same thing that happened to modern agriculture. There are agricultural people in agriculture in a different way, you know, crowdfunding and all of that. And you know, after a while, about 2 years, government began to pay attention in that sector. So that's why it is important that as engineers, I know we might not always have it all, and our own career is one that is capital incentive, so to speak. But when we make the right noises, when we do the right things, we begin to learn, we begin to, you know, this person does a small startup, this person has learns this software, you know. Sometimes you can do something, you can even enter into competitions, hackathons, and then you are recognized, you know, and then people say, oh, what's that person? They begin to learn about it, the public begin to learn about it, the government begin to understand what you're talking about. So I think it's really important that, you know, we take lessons. So thank you so much, Dr. Joshua.
You're welcome.
Any other question? If you have any other question for us, if you have any other question for us, there's anyone, okay, let me just know. I will just ask him one question. Okay, somebody say, what's the practical starting point for a beginner in AI or general IT? A step-by-step approach. Well, I'm not sure I'll be able to give you a total step-by-step, but yeah, I'll let him answer the question.
Practical starting point, start reading books. I mean, that is the way I started, because of course I moved from mechanical engineering into AI. It was not easy. So when you start and reading books, you start seeing the gap in your knowledge, right? And when you see the gap in your knowledge, you know the other things you need to learn in order to like understand to move forward. And when you do that, then you continue to improve and get all the things that you need. So I think just start reading books. Take any book in, I wouldn't say any book, but take recommended books for artificial intelligence or IT and start reading it. You won't understand in the first time, but the more you do it, you get to know it more.
Okay. Yeah, so thank you very much, Dr. Joshua. I think that's really very important. So can you recommend some books? If you can just drop one or two books in the comment
sure.
section. I know you can Google them, but if you're kind enough to, if there's anyone that you know, I think you will drop it in the comment section for us. But yes, that's really very beautiful, very nice. I don't think there's any other question. I'd like to say thank you. Can we say thank you to Dr. Joshua in the comment section? Just say thank you. It's taken a lot of time to put together that presentation. He's been very busy. I think this is the second or third outing today speaking, and we really thank you for speaking to us. I think, can we say thank you to him in the comment section? Just say, tell him thank you.
You're welcome, everyone. Thanks.
Appreciate you sharing the knowledge. Thank you. So it's going to drop those books in the comment section while I move. All right, I'll just unpin you and then pin myself back. Replace pin. All right. Oh, somebody saying, can you have his contact? I don't know if you like your personal contact, but you can always check him up on LinkedIn. Is that correct, Dr. Joshua? I think he's muted himself back, but yes, you can check him up on LinkedIn. The name is Joshua Oweyemi on all platforms, Facebook, Twitter. I know he's active on Twitter also. You can contact him, Dr. Joshua Oweyemi. I'll just type his name
I can
in
share
the
my
comments
email
section.
if you don't mind. Yeah.
Okay, you watch it. That's fine, please. Please go ahead. You can share your email in the comment section. That's fine. If you're happy to share it. So you can contact him, ask him, I'm sure. You know, he's a nice person. Give us relevant answers. So yes, and they can also find you, Dr. Joshua. He also has a YouTube channel. So you can go on there, check all these questions about step-by-step and books, and he has a lot of recommendation about what's going on today. All right, so he just dropped his email there, tjosh.oweyemi@gmail.com. So please do well to check him out. Thank you so much.